So as promised, before I go to our practice problem, I just want to address what a segment of a circle is, okay? And when we say a segment of a circle, we don't mean like a regular segment. We mean the slice of a circle that looks like this. And basically we draw some kind of a chord, and this piece that's cut off, that's a segment of a circle. To find the area of segment, we actually have to, there's no like direct formula. We have to find the area of the entire sector and then subtract the area of this little triangle, okay? And the difference will give us the area of the segment. So that's what this formula is. Okay, so now let's move on to our practice problems. So first one says convert to degrees. So remember, to convert to degrees, we multiply by 180 over pi. Okay, so that's what we're going to do. 180 over pi. Okay, the pi's will cancel. Okay, 6 and 180, I can divide both of them by 6. So that's 30. 5 times 30 is 150 degrees. Okay, same thing here. This one is even easier. We're going to multiply by 180 over pi. Okay, the pi's will cancel, and we're left with 180 degrees. Okay, to convert to radians, on the other hand, we're going to use the same proportion, but we're going to flip it, since we want now the radians to be on top. So pi, and we want the degrees to cancel out. Okay, so 45 and 180 both can be divided by 45. That's 4. So this is just pi over 4. 60 times pi over 180. Again, 60 and 180 can be both divided by 60. So this is pi over 3. Okay, so I hope this is really simple. Just remember this conversion factor. Okay, now find the length and arc of the arc. Okay, so before you decide which formula to use, you have to make sure that you know what unit is used to represent degrees. So the angle, sorry, not degrees. So in the first one, we're using degrees, which means we're going to use that long formula. So the length of the arc, we're going to do the central angle over 360, and then remember, circumference of a circle is 2 pi r, so we're going to multiply by 2 pi times the radius, which in this case is 5. Okay, so let's simplify. This is 1 and 6. Okay, so 2 times 5 is 10 pi over 6, which we can simplify to 5 pi over 3. Okay, to find the area, remember, area of a circle is pi r squared. We're going to use the same exact fraction, 60 over 360, multiplied by the area of a circle, which is pi times radius squared. In our case, that's 5 squared. So again, we have 1 and 6. Okay, 5 squared is 25, so 25 pi over 6. Okay, now here, as you can see, the central angle is given in radians because the pi is a giveaway that these are radians. Okay, so we are going to use the simple formulas. So the first formula is, remember, theta times radius for the arc length. So theta is pi over 3, and our radius is 5, so this is just 5 pi over 3. Now I purposely used, if you were to convert, I used the exact same angle. One is written in degrees, one is written in radians, so that you can see that we are getting the exact same answer. Okay, now for the area, we're going to do 1/2 of the theta times radius squared. So theta was pi over 3 times radius squared, which is 5 squared. And again, 5 squared is 25 pi. 2 times 3 is 6. We got the exact same answer as in part A. Okay, so a lot simpler. Okay, now final question. Find the area of the given segment. Okay, so remember, area of a segment is equal to the area of the whole sector minus area of the triangle. Okay, so sometimes for the triangles, unfortunately, you will have to use either your 45, 45, 90, 30, 60, 90 triangles, or you will have to use the triangle formula, remember that, and I think on the assignment you need to use that. Remember, it's 1/2 AB times sine C. Okay, so you might have to figure out what the area of a triangle is using a little bit more complicated math. In our case, we have a right triangle, so it's super simple. Okay, so area of a sector. Okay, area of a sector is going to be, this is 90-degree angle. So I'm going to do 90 over 360 times pi times radius squared, which is 10. Okay, 90 over 360, that's 1/4. So 100 pi over 4, which equals 25 pi. Area of a triangle is going to be 1/2 times base times height. And 1/2 times 100 is 50. So the area of the segment is equal to area of a sector minus area of a triangle. And in this case, since these are not like, we can combine them. So this is our final answer. I hope this helps you with your assignment for today.